So we began discussing classes and objects yesterday, right? Classes and objects become basic building blocks of object-oriented programming. Class is a user-defined type. It acts like a template. Class essentially consists of state and behavior of its objects. Variables which are declared in the class are all part of state, and methods define behavior. This keyword refers to current object. A method which is defined inside a class can be called through some or the other object of that class. Methods become important for us. The most challenging part of writing the class lies in writing methods only. Since a method represents an operation, at the time of writing the method, you have to carefully decide its signature first. These decisions quite often are taken collectively. Decisions regarding return type, name of the method, number of parameters which it must possess. All these decisions are taken collectively generally. Soon after deciding signatures of methods, people generally declare them inside interfaces. And later on, interfaces are implemented. Okay. For example, this is a new Java project, and shall call this as OOP. To this project, you add a new Java class. And let us call this class as, so we shall write a business class now. Like savings account. Okay, now see, one can even develop an interface in Java. Okay. Interface simply contains method declarations. Definitions to all those methods that are present in the interface can then be developed inside classes. So interface acts like a guide first. Source code pertaining to interface can also be saved in the same file called .java. Okay, .java extension file. And interfaces are also compiled into .class files in the end. So interface is also like one class, but simply contains method declarations like public, void, deposit, int amount. Public, void, withdraw, int amount. Public, double, get balance. In this manner, people simply declare methods in an interface. For every method, simply the header is declared and there is no body. Header is terminated there itself. Methods such as these are actually called as abstract methods. Okay, abstract methods are those which are simply declared but not defined. So here, by seeing an interface, one can understand method specifications. Okay. This void is a keyword with the help of which we can declare and tell the compiler in advance that our method does not return any value. Just before the name of this method, there is the keyword double appearing here. This implies that from the body of this method, which we are going to write later, in the end, we are going to return a double value. So methods are of two types, void methods and return type methods. A method can return any type of result in the end. After doing its work, a method can return a result, and that result could be of any type, double type, int type, string type. But if a method has nothing to return, right? Say its work is such that after doing its job, it does not have to return anything, then just before its name, you write void. So here we go. After defining an interface, then one another programmer may come forward and start writing a class. I will call this class as savings account IMPL. In this class, I want to write definitions for all these three methods. First, I shall declare variables int account ID, string account holder name, double account balance. In real-time scenario, there will be many more other variables which also have to be declared in a class. For now, let us keep the example simple and limit ourselves to this extent of declaring only three variables. Now, to see that these variables are initialized on behalf of the current object, I will write one method like this, public void set data. Okay. This method was never declared in the interface. But yet, no. So now let me show you first of all relationship between the class and the interface. To relate class with the interface, you can use a keyword called implements and then write name of the interface there. So your class called savings account IMPL implements savings account. So compiler will be continuously then reminding you that methods which are declared in this interface must find their definitions here in your class. The process of redefining methods which are already declared in the interface inside a class is called as method overriding. Method overriding. Now, see, just place the mouse pointer at the red colored underline and then tell Eclipse to add unimplemented methods, and in no time Eclipse will add all those methods with empty stubs, those which are declared in the interface. At the rate override annotation is only an optional annotation which will let everybody know that or understand that this method was once declared in the interface and now it is getting redefined from the class. So those methods that are dictated by interface should preferably be having this annotation above them. However, presence of this annotation is optional. In addition to these methods coming from interface, the class can possess its own methods too. For example, public void set data. If a new savings bank account has to be initialized with data, then one must supply three arguments: ID, account holder name, and balance. This method can then assign data present in these three parameters to these three variables. These three variables will be present inside the current object. Therefore, each one of them can be accessed like this. This dot account ID is equal to ID. Take the value present in this variable called ID and assign it to this dot account ID. Similarly, this dot account name is equal to name. So we are assigning values which these arguments brought to this place to the instance variables of the underlying object. The underlying object is nothing but the current object. Next, this dot account balance is equal to balance. So only after calling set data, we will then let deposit method, withdraw method, and get balance method to be called. Now, deposit method. Deposit method takes an int as an argument. Int represents the amount which needs to be now added to the balance. So, in the deposit method, logic can be developed like this. This dot account balance is equal to this dot account balance plus amount. In a real-time practice or a scenario, there will be much more complex code inside the definitions of methods. For now, what great thing our methods are doing is not important, right? So how to write a method? What is meant by return type? What is meant by argument? These concepts are what we must thoroughly understand first. So I'm trying to keep that business logic as simple as possible now. And one more thing that I just got reminded about is, see, this lengthy expression, this dot account balance, had to be repeated again on the right side also, right? Right side of assignment operator. Now, in order to shorten this statement, you could use plus equal to operator. This dot account balance plus equal to amount. This statement will be internally expanded as this dot account balance is equal to this dot account balance plus amount. Now, withdraw. Withdraw method shall have a little bit of business logic also involved in it. See, if customer is trying to withdraw certain amount of money, it becomes duty of the application to first check whether there is sufficient balance or not, right? So let us perform that validation like this. If amount or if this dot balance is greater than amount, this is the amount which the customer is trying to withdraw now. If this dot account balance is greater than amount, then only do the transaction, else show error message. System dot out dot println transaction rejected. Now, if this dot account balance is greater than amount, then this dot account balance minus equal to amount. System dot out dot println transaction carried out successfully. Right? Or you could say withdraw transaction was successful. In here, withdraw transaction got rejected. And get balance. I could have written get balance method also as a void method. See, a void method does not contain return statement in it. In fact, it has been already decided in the interface that getBalance must be working as a method that returns a double type value and does not take any parameters. Now there is no way that we can change its signature because our class has already taken the responsibility of implementing savings account interface. If a class declares that it implements an interface, then it becomes its duty to override each and every method that belongs to the interface by maintaining return types, names, parameters as it is, as how they appeared in the interface. So let getBalance method return the current object's account balance to whichever expression calls it. Thereby, whoever calls this method will be able to get the balance, and with that balance, they can do some other operation. So void methods generally perform operations which resemble transactions. Return type methods generally perform operations which resemble calculations, and so on. Okay, so in addition to all those methods that are declared in the interface, a class can possess its own methods too. For example, here we wrote a method called setData. Let us write one method called showData, public void show details. And let showDetails method simply display ID and name only. This dot account ID, system dot out dot println name is equal to plus this dot account name. As far as balance is concerned, there already exists a method called getBalance, right? With the help of which balance can be obtained into any other area in the project. In this manner, in a class, we declare variables and write methods. Against each one of the operation that has to take place, we have to write one separate method for it. Now let us create object of this implementing class, call these methods and test them. You cannot create object for an interface. Duty of an interface is to simply declare methods. It is like a list of method specifications, which will be developed first in the project in the initial stage. So people first write down return type, name, parameters in an interface, and then leisurely they implement or override each and every method. So interface is like a plan that lets everybody know how many methods are going to be defined and what must be the return type, name, and parameters of every method. Now to this project, I'm going to add another class. Let me call it as main app. And this class shall contain the main method now. Okay. So in one project, You can find many classes like this. And further, for properly storing the classes without encountering overwrite problems or name collisions, people create packages also. We'll create packages later. Okay. Now, so here we are going to create object of this class, savings account IMPL from OB is equal to new savings account IMPL. Now this newly created instance, so new is used to instantiate a class. Okay, so what is new used for? New is used for instantiating a class. Instantiating, it means the process of creating object of the class. For every newly created instance, compiler will allocate memory. Amount of memory allocated by compiler depends on number of variables which are declared in the class. The savings account IMPL class has got 3 variables. So every new instance of the class will tend to have all those 3 variables inside it. So object can be thought of as a wrapper around variables. Now to see that those 3 variables which are present in this new instance are loaded with data, I will take the help of set data method that is present in savings account IMPL class. Without using an object's reference, you cannot call a method like this. See, error. Because your project could be having several classes, and if you try to call a method from one of those classes without telling or without showing through which object that method has to be invoked, then compiler cannot understand, right, where to go, into which class it must go in search of the definition of this method now. So error. When you are calling a method, you have to call that method through some or the other object of the class. Here OB actually acts like a reference variable. It stores reference of this newly created object. Only for our convenience, sometimes we may call reference variable itself as object also. But truly speaking, object will not have any name. Newly created object or newly created instance will not have any name. It will have some or the other reference internally generated for it. And OB is a reference variable, means a variable that contains reference of that object. So through reference variable of some or the other object only, you have to call a method. Now, set data. Even the compiler knows that set data at a time when we are calling set data, it becomes our duty to specify 3 arguments for it, all according to the definition that you wrote. See here, you declared 3 variables and kept them ready. Into these 3 variables, you must first send data from the area from where you are calling the method. Let us suppose that there exists one account whose ID is 1212 and say a person called John owns that account, and say John opened the account with this initial balance 4,500. Now this call binds perfectly with the definition. Binding, that binding will be done by the compiler. Compiler goes now all the way to savings account IMPL class. How does it know now that it must go to savings account IMPL class? The OB was declared as a reference variable of this type, right? Savings account IMPL. So it now goes all the way to savings account IMPL class and searches for a method called setData. At the time of going there, along with it, it takes the reference present in OB, okay, and also copies of these three data items. Goes all the way to savings account IMPL class and arrives here. Then it stores reference of that current object which it brought along with it inside this. So this appears like a keyword to us, but internally this will be acting like one reference variable again. And this always contains reference of the current object. Current object is the object on behalf of whom method is currently invoked. Without this, there is the compiler after coming into setData method will not be in a position to know which object's account ID and account name and account balance it has to access presently. See, every object of this class, for example, savings account IMPL, some SB is equal to new savings account IMPL. Now here there comes one another object. And this object also will have its own variables inside it. ID, name and balance. So at a time, if the current object is not known, then compiler will not be in a position to decide whether it has to presently access account ID, account name and account balance of the first object or second object. Okay. So it must know clearly as to on behalf of which object this method is currently called and invoked. And therefore internally it uses this here. Into this, reference of the current object will be automatically sent. Via this, compiler can then understand which object's account ID, account name and account balance it has to presently access. Now these three variables which are declared at the header are generally called as parameters. When you are viewing the method's definition, well, you call them as parameters. When you are viewing the method call, see here, this is the calling area. From this angle, well, we call these three as arguments. Okay? And from this definition point of view, we call them as parameters. Parameters are nothing but those variables which are declared within the header of the method. If further method has some more variables inside its body declared, for example, int x, say for some obvious reason, you have to declare one more variable called x inside the body of the method, then you must not call that x as parameter. It is a locally declared variable, declared for some purpose. Only those variables which are declared within the header are called parameters. And since these rounded brackets hold them all, well, these rounded brackets are called as parenthesis, parenthesis, parenthesis. They are called as parenthesis because they hold parameters. For each parameter, you have to declare data type and name, data type, name, data type and a name. Professional programmers tend to declare these parameters also with the same names as that of the variables which are declared inside the class. Okay, see these variables which are declared inside the class are actually called as instance variables. because they will be present in every newly created instance. They're called as instance variables. And to understand correlation between one parameter and one instance variable, programmers generally tend to declare parameters also with same names, account ID. Okay. So what I'm showing you now is the widely adopted practice, account name, account balance. Okay, I did not choose to declare these three variables also with same names in the beginning so as to avoid confusion. I thought let some initial idea right arrive in mind, then I could introduce you to this, right? Now it is very easy to understand the correlation between one parameter and one instance variable, right? Account ID is equal to account ID, right? Now locally declared parameter and instance variable both have same name. Even then compiler will not get confused because instance variables are accessed via this keyword, right? So this dot account ID means this account ID, which is an instance variable, and simply account ID is nothing but the parameter. So compiler clearly knows that difference. Therefore, instead of declaring parameters with altogether different names, right? Use the same names with the help of which instance variables were also declared once. Then you don't have to remember two different sets of names, right? See, in real-time practice, in a class, you could see more than 50 instance variables. Okay, so I'm not exaggerating the situation. You just think about it. In a real-time scenario, if you open a savings bank account anywhere in a bank, will the bank authorities say it is sufficient if these three things are filled? Account ID, account name, and account balance? No. On your behalf, they will load lots of other data into the system, like your date of birth, your citizen ID, your address, phone number, email ID, and many things more, right? So therefore, suppose that there are 50 instance variables, and here obviously 50 parameters will have to be declared. And for these 50 parameters, if you keep on finding new names again, altogether different set of new names, then you get overloaded with that aspect of remembering them all. So it is better to declare parameters also with same names as that of instance variables, and later show the distinction between parameter and instance variable by explicitly using this before instance variables. So at the time of branching from the method call to the method definition, the compiler takes reference present in OB and copies of these three data items with it, comes over here, assigns reference to this, and stores 1212 in account ID, the value John in account name, and the value 4500 in account balance, and then enters the body of the method. Thereafter, it takes those three values from these parameters and assigns them to the instance variables of the current object, and thus current object is now loaded with data. Similarly, SB dot set data, say 1515, Martin 6000. And thus second object. So now whatever reference is present in SB will be carried into this. So this will be always pointing to current object. And once method invocation happens and control comes out of the method after executing the code, these locally declared parameters will be simply destroyed. Okay, so all those variables which are created as soon as the method is invoked will be automatically destroyed when the control returns back. And if the same method is called again, once again, memory will be newly allocated for the parameters. So every time method is invoked, compiler will have to allocate memory for all the parameters afresh. Yes, now on the first object, let us perform one deposit operation. Okay, OB dot deposit 200. So once again, what will happen if we don't show object to it? Error. Why? Because it is not known now to which savings bank accounts balance this 200 must be added. Therefore, OB dot deposit. See, picture is crystal clear here. Deposit operation is taking place on this object. And what is that object? It is a savings account MPL object. And such a clarity could only be achieved through this object-oriented programming style. In procedural style, well, you don't see objects at all. You could, of course, write functions in procedural style. When a function is called, well, there wouldn't be any clarity as to on which object's data that function is going to work presently in procedural style. But in object-oriented programming, it is all crystal clear because we do operations only through objects. Next, on the second object, let us perform a withdrawal operation and try to withdraw 500 from it. Now, OB dot show details will show details of the first object, but it will show only ID and name. And to know the balance which that first object has, you could do like this: system dot out dot println current balance or present balance is plus OB dot get balance. See? Purposefully, I wrote get balance as a return type method, so as to let you know how void methods work and how return type methods work. A return type method can be called from within any other expression like this, so that after doing its work, this method will bring back some value, and that value is then given to system.out.println so that it gets printed here. If not to system.out.println, you can do anything else, whatever you want with that balance. You can subject it to some other operation further, like having to calculate interest on it. So since balance of an account may undergo several calculations while keeping future needs in view, I wrote it as a return type method. After all, I could have written it as a void method. Void method, then simply no, the one which displays balance, simply using system.out.println inside it, not returning it. Okay, but in that form, I thought method would not be so useful because it is balance. Generally, with ID and name, people don't do any arithmetic operations, right? So I wrote the method which displays ID and name as void method. But coming to balance, since people may perform arithmetic operations on it, well, I chose to write it as a return type. Like this, at the time a method has to be developed, you, in collaboration with all others who are also working in the same project, will first decide signatures. Deciding signature of a method is a design aspect. For all the methods, first signatures are decided and then leisurely people write definitions. By the time the phase during which definitions have to be written arrives, people may forget as to how many methods were once thought to be present. Therefore, soon after deciding that a particular method must appear in the class, people will first declare it in an interface. See, before going to a shopping mall, don't you write down all the items that you plan to buy right in one paper, right? You write names of items and their quantities. That is just a plan. Say you are going to supermarket to purchase grocery items and say there are somewhere around 10 items to be purchased. So to ensure that you don't forget any of them, what would you do? You would first write them all on a piece of paper, right? Their names and the quantities. You carry that paper to the supermarket and following that paper, you will then buy the items. Similarly, before writing definitions in a class in Java, people have a tendency of generating interfaces first. It is not mandatory. It is not mandatory that you write an interface and then only write a class. But it always stands out to be a good practice, a standard practice followed uh, widely in the industry. Okay? Yes. Now, in main app, so here we found get balance, show details, set data, right? Savings account IMPL. Okay. Now let us try to show balance of the second object also. SB dot show details and then system dot out dot println present balance. And in between data belonging to the first object and data belonging to the second object, let there appear a line of separation like this. Okay. Oh, here we go. Run as Java. First object.
There, it should be changed, I guess. The last one, SB dot get
Oh,
balance.
very good, very good. Yes, that is a copy paste problem. You're right. Okay? Yes, it must be changed to SP. Good, very good. Yes, that's what even I was wondering here. So how come the balance are same? Yes.
Yes, sir.
So you must use the right object too, right? One must use the right object also. Now, see, even you could quickly understand that I was, following a wrong path and doing something wrong. Why? Because basically this paradigm is such object-oriented paradigm. You could easily locate the bug. And fixing also became easy now. So debugging becomes easy to the programmer if object-oriented style is adopted. Yes. So now let us run the program again. Yes. So I remember opening first account with the minimum balance 4,500, right? Sorry, initial balance. Then later, since 200 was deposited, it became 4,700. Second object had 6,000 as the initial balance, 500 withdrawn, therefore 5,500 remained. Suppose that from the second account, say we try to withdraw 7,500 while there is only 6,000 balance. So let us see whether that validation is really working or not. Yes, see, withdraw transaction has been rejected. Okay. This outcome actually belongs to the second one. Okay. So since withdraw rejected, the balance remained 6,000 as ever. If you want, you can make this message come up, right here. All right. It's a matter of placing statements in correct places, right? So this is all what happened on the first object. As far as second object is concerned, withdraw transaction was rejected and therefore the initial balance remains 6,000 as ever. However, if you try to withdraw only 1,500, transaction was successful and therefore 4,500. See, what we are developing now is part of application layer. Okay, code such as this generally runs behind graphical user interface, behind UI. So if there is UI around this code, then data such as this, the ID, name, balance, can all be entered through that UI. UI consists of forms, data entry forms. For now, there isn't any such arrangement made, right? Therefore, we are feeding data directly within the source code and testing the application layer. Okay. All right then. So through this example, we try to understand several things as to what is meant by class, what is meant by an object, what is meant by this keyword, what is meant by parameters, what is meant by not returning anything, and what is meant by returning something, and why we return a value. And then we even studied about interface, right? The importance of writing one interface first. Interface acts like a guide. It provides guidance. It takes us in the right direction. A programmer whose duty is to write a class can know for how many methods he must write definitions as part of the decisions that are already taken through interface. Okay, and here we came across the keyword implements also, right? And we understood its meaning. Well, any doubts regarding the concepts that are discussed today, you can ask me now. Anurag,
Nothing, sir.
Ashish. Okay, right.
Everything's clear, sir.
Okay, clear, right? Okay. Now, see, you could write a method such that it does not return anything and takes one or more parameters. Or sometimes you can write a method such that it does not return anything and does not need any parameters. So details, the duty of this method is to, after all, show data which is already present in the current object. So it does not require any additional inputs to be coming in the form of parameters to it. And sometimes you may have to write a method such that it does not take any parameters but returns something in the end. And one another kind of method that you may have to write is a method that takes parameters and also returns something. Depending on the requirements which other programmers have with respect to your method, you have to decide your method signature correctly. After you define a method, some other programmer will call it. For example, somebody wrote a class called scanner, and what have we been doing since from the beginning of this course? We are just creating an object of scanner and calling methods, predefined methods. And we found that all methods in the scanner class were really useful. It is so because the programmer, whoever wrote scanner class, decided their signatures rightly with respect to number of parameters and return types everything was decided in a manner that whoever is calling those methods now finds them very useful. You should also attain the same spirit. When you are asked to write a definition for a method, you must first study the requirement. You must thoroughly know which operation is it that your method is supposed to do, and then decide whether to write that method as a return type method or void type method. If programmers who call your method expect that the method does some work and does not return any value, then write it as a void method. So you have to decide everything in consultation with others. It is a teamwork, collaborative work. Okay? Number of parameters, types of parameters, all these things must be decided carefully according to the requirements which other programmers have. All right, then we'll end the session here for today. Tomorrow we'll discuss some more concepts related to methods, purely on methods. Until complete understanding is attained on methods, well, we will not discuss other concepts like static members, constructors, etc. First, the spirit of writing a method must be understood. Next, syntax. Yes, spirit of writing means why we need it, why we are writing it. These days, generally in interviews, people ask you about application of concepts, okay, not syntax. Okay, where exactly a particular concept becomes important, why we need it. Well, these are the things they ask, right? So to attain further understanding about methods, let us do some more examples. However, we shall continue tomorrow. I will upload this recorded session and will also keep this source code posted to that drive folder. Okay. Right. All right.
Sir, can you share us this the new drive link if you have it?
Sure. Yes, sure, Marsha. I will definitely. I will ensure that all of your names are added. Okay.
Yes, sir. Thank you.
Right. Thank you.